Okay, so make sure I don't trip over anything here. We're going to start this video off a little bit, or maybe this video series off a little bit different than usual. This whole like kind of Saturdays are for the toys series is just going to be a little bit more raw, maybe more detailed in some cases comparatively to what we usually do for comparisons and stuff. That's because I've kind of set aside the time now to strictly work on the race cars on Saturdays. In this video, I kind of wanted to go through some of the new stuff that we have for the Mark III drag car. So for those that are new to the channel, maybe Clayton can add in the odd clip of us running that car before. We have a sport front wheel drive Mark III drag car. It's a 16 valve cylinder head with essentially an 06X, 06A kind of block, which would be a 1AT block or a 2-liter block because they're all basically the same. So kind of like a 1AT bottom end, but with a 16 valve cylinder head. The best times we've run in that car is a 920. We've run it multiple times at probably only around 700 horsepower. The last time we had the car in the dyno, it made around 850. But last season, when we switched to a new turbo and we hadn't run the previous year because of COVID, we really struggled out at the track last year. So we're going to probably struggle a whole lot more this year because we got a whole bunch of new stuff to work through. But I want to tune the new engine. We got a new engine package going together, and I want to tune it as safely as possible, and I want to go as far as I can with this thing. So we have a bunch of new stuff. As you can see in the background, there's a little Haltech bag back there. We're going to go through some of the stuff that is on deck to go in the car this year, some changes that are going to happen with the car, and then also we're going to get into probably today doing some modifications to the intake manifold, potentially exhaust manifold, depending how far we get with it. So let's get into some of the stuff that we got. Okay, the first major thing we're changing this year on the drag car, as you can see, we're switching to Haltech. And not just any Haltech ECU, we've gone with the Nexus R5. And for those that don't know, this is an ECU and power management unit all in one. So all the fuses, all the relays, everything are going to be gone, and everything is going to be controlled specifically by this unit here. So this is going to be a huge change for us. I've never used a PDM or PMU unit before. However, what better way to jump into it than with something that is completely integrated in with the ECU that you're using to control the engine. So I'll get into more details what's involved with this as we continue on, but this is the ECU that we went with. We are trying to make a lot more power in this thing this year, and I wanted to do it as safely and reliably as possible. So with that, I wanted to go with something new that's more modern and keep me going for quite a while. So this ECU only came out about a year ago. With that, we went with the thermocoupler. This is all cam based, so we're going to have 4 EGTs, as you can see. This is just going to connect through the cam, so very simple to wire in. Once we hook those sensors up, we're just going to plug in to the cam network. That's going to be very easy. Also, we went with a CAN keypad. I think I have this open. There's no numbers or anything on it right now, but this is CAN keypad, so controlling, firing the car, shutting the car off, lights, anything like that, even boost control. There's all kinds of stuff you can do with that. Again, all wired in through CAN, so very simple to operate. The other thing we went with was Haltech's unterminated harness. So it's unterminated on one end, I guess, but it's terminated on the ECU side. All the wires and colors and everything match what's in the ECU already. A lot of this stuff is labeled of what it's going to be used for. Robbie's going to sit down and lay it all out and get a good idea what we're going to require in the car, but at the same time weed out anything that we know for certain that we're not going to use, so we don't have a bunch of extra wires cluttering it up and adding a bunch more weight or a bunch more, but this stuff does add up. This is a pretty heavy bundle of wire. So we're gonna lay that all out, start depinning some of this stuff out of there, and then all we gotta do essentially is just pin in the sensors that we require, whether it's throttle or coolant temp or whatever. And that's it, because as mentioned earlier when we were talking about the ECU, there's no fuses or relays required, so it's literally going to go directly from the ECU to the device, whether it's a throttle body or wastegate controller or whatever it is. So it looks very, very daunting, this huge bundle of wire, but it actually is really simple, and it's going to make wiring this thing very, very easy. With the wiring and the sensors, I also went with some of these 2-in-1 pressure and temperature sensors. So now that's also going to cut down on some of the wiring, because for a coolant pressure or coolant temperature or oil pressure and oil temperature, it's all just going to be through one sensor now. So there's 3 wires on it, and that's going to make that cut down on a little bit more wiring and make things troubleshooting a lot simpler when it comes to overall days at the track. So and that's, I think, a new map sensor for, maybe I'm using that for boost. I can't remember exactly. I have a few of these sensors kicking around. We got ethanol content sensors, or connectors as well, so that we can wire in an ethanol content sensor, because I am going to set it up on flex fuel, mainly because of just moving the car around at the track or here at the shop. It's going to make things much easier when I don't have to worry about specific ethanol content. I can tune for whatever we're running. So that's ethanol content sensor there. And I have this pretty slick adapter piece that goes in the return line, and it allows me to run a -10 return fitting. Give me a second here. Let's see if I can. Kind of goes. We go like this. Sensor like that, and connects. You can kind of get the gist. So because this is such a small hole for us, we run -10 lines. There's no way that we can run -10 feed and then trying to feed all the return back through this small sensor. So this allows us to run -10 return and just easily be able to put in a regular ethanol content sensor that everybody uses. So enough bambling about that, moving on. Okay, next up, ignition stuff. So as mentioned, I'm using a 16 valve cylinder head on basically a 1AT block. The 16 valve came with the distributor. So USRT makes this fancy adapter conversion for us to be able to run a 1AT cam trigger on it. This will allow us to run sequential fire opposed to us running batch fire that we always ran. I'm also going to run a set of APR coils on it. For tuning purposes, for like big horsepower, it's not going to make a huge difference running between batch and sequential. The difference will be where now, as mentioned, we're running the EGT sensors. We'll have the ability with sequential to be able to control fuel per cylinder, which I never was able to do before. So that's going to really help keep the thing together. Next up, this is kind of a new option as well that we're going with, and it's going to be interesting to see how all this plays out, but I'm very, very pumped about trying it out. We went with a Turbo Smart E-Gate. The Nexus R5 enables, it's able to control a wastegate, electronic wastegate directly from the ECU. There's no modules or adapters or anything like that required to run it. We can run a full electronic wastegate like this guy directly from the ECU. So part of the reason I went with this is it's just new tech. We're doing some new stuff. We have an ECU to be able to do it. We may as well try to run it. Also, because we're running that 6785, it is very laggy on that engine, at least with the old setup it was. So we're going to do everything we can to keep this thing spooled up as quickly as possible. And with an electronic gate, it's essentially has the ability to be able to do that because the gate is closed completely until the ECU tells it to open, where on a springed or a spring style actuator, basically because it's mechanical, it's always going to be starting to open a little tiny bit before you've actually hit your boost target. So let's say the boost target is 20 pounds of boost. That gate or that valve isn't completely closed until it sees 20 pounds. It's starting to open before that because it's the nature of a spring. So with this, it's going to be slam shut until it's triggered to open, which in turn should help that thing spool a little bit quicker, which is exactly what we need on it. Okay, next up, set of cat cams. I probably won't get into digging these out. They're a billet set of cams from Cat Cams, as you can see. What we did is when the cylinder head shop had our cylinder head doing the bigger valves and all that stuff, we had it flow benched, and I reached out to both them and Cat Cams and a couple other companies and basically said our target is 1,000 plus wheel horsepower. You know, what can you recommend for a cam? A couple options came up. We kind of discussed it back and forth with the cylinder head shop, and we went with these guys. So hopefully we can score a bunch of extra power with these because we were running a relatively conservative cam on the old setup. As mentioned, it made like 850, and that was after we started playing with the cam degree. It was making around like 750 at similar boost, 750 to 780 or something like that, and then we started playing around with the cam sprocket and adjusting the degree of the cams, and we scored like an extra 80 wheel horsepower around similar boost. We wanted to go further with it, but as longtime viewers would know, the thing spun a bearing basically on the dyno, so we had to cut that short. So we're building a new engine anyways. I wanted to try a bigger cam, and it looks like this thing is going to fit the bill for the power that we're shooting for. So what else am I forgetting here? Small thing. This is a bracket. I don't even know who I bought it from. It's basically to run a drive-by Mark IV drive-by wire throttle body in a Mark III. I think I'm going to switch to drive-by wire. It's not typical, but I kind of want to use it as a fail-safe, and lots of modern cars go really fast with drive-by-wire throttle body. So I figure if we're switching all this over, we may as well look at a new throttle body, probably the 80 to 90 millimeter. I think the one I have on the car now is a 90 millimeter throttle body. But to have full control and to have fail-safes built in if something goes wrong, the ECU can shut the throttle plate a lot quicker than I can process and take my foot off the throttle. So we're thinking about switching over. I don't know what throttle body I'm going to run yet, maybe an LS one or something like that, but that's yet to be determined. But that piece enables me to just bolt in a Mark IV throttle body, which makes life a lot easier for me. So I think that's it for the most of the new parts. There's a lot of stuff there, and there's a whole bunch of stuff for the engine itself. As mentioned, you know, we got a whole new engine package going together, but that is yet to come. Today we're going to go through some of the wiring and start working on the intake manifold and stuff like that, because we got a bunch of stuff to do to this engine before we can get the new setup back together. Okay, the harness. As you can see, it's all laid out nicely. This is basically, these are the wires we've taken out, and this is going to be above and beyond all the extras that we think we may possibly need at one point in this harness. So we've taken all this out, and we still have tons of extras in here that we still might take some of it out. There's 3 CAN plugins in this harness, so it's going to make it really easy to add additional things in if we want to, like if I decide to put a dash in it or something like that. And also with this harness, they give you all shielded cable for all your triggers and knock sensors and stuff like that, so that's really awesome. So yeah, all these are the inputs, outputs, a whole bunch of additional things that we'll require, and we probably won't see more of this harness until we start laying it in the car and start terminating where each sensor actually needs to go, and then actually putting the sensor on the harness. But as mentioned, It's basically going to go ECU directly to the sensor, and then no fuses, no relays, nothing like that. This is the whole entire operation right here. Okay, some other things that we picked up on today while kind of going through everything. These new cams are billet cams and they're hollow. And in order to run these trigger setups that I showed you guys earlier, on a 16 valve, you need to drill out the end of the cam in order to get this all bolted up. Well, because it's hollow, we're going to have to come up with another solution for that, which I have an idea, but that'll be in a future video once we get a little further on with it. Okay, so some of the stuff that needs to happen on, well, not this engine, because obviously this one's toast, but the parts that we're going to swap over to the new engine, which is the intake manifold, fuel rail, and the turbo manifold. To keep getting my hand in the way, and it's focusing on that. But on this flange for the intake manifold, the injector O-ring is not the greatest design, and the O-ring kind of sits on that lip in there, and under high boost it wants to push the O-ring up the injector and cause a major leak. It's not ideal, not that safe. I kind of taped up around the injector in the past to try to keep the O-ring from moving. So this intake manifold's got to come off. I got to try to either weld this up or machine it out a little bit better so that the O-ring can kind of sit down in a hole. Also, this has been a couple times now, it's been like this, but we're getting the gasket pushing out through the manifold, so I got to take this all apart and address that. And then on the exhaust side, we need to weld in the bungs for all the EGT sensors, because now we're going to run 4 EGT sensors on this thing, and I'm going to be using a cam sensor as well, and I have a new piece from USRT to give me cam trigger, but the turbo's in the way, so I got to move this out a little bit. And as you can see, this is a separate piece that I built, which is ideal because I've modified this multiple times through the different turbo changes and stuff. So all I'm going to do is modify that again to sit it out a little bit different, making things much easier. So time to get the intake manifold off. That's where I'm going to start, and see where it's going to take to fix this thing. So I grabbed an injector. This is just a junky stock 180 injector, but to explain what I was getting at, the face of the O-ring is the only thing sitting on that, not the greatest light. So under 45, 50 pounds of boost, it wants to push that O-ring up, and every injector is different. This has a pretty big lip on it, but the injectors that were in the car, not quite the same. So yeah, ideally I want this O-ring sitting down in a hole essentially, so the sides of the O-ring, the bottom of the O-ring is all touching. Right now it's just kind of a small part of the bottom. So I gotta, basically my thought is weld all this up and then re-drill it out, machine it out, whatever, to make it proper. So, and as you can see by all the color, the fuel is leaking out of here. So we're gonna fill these in, kind of like what I was explaining. I'm gonna fill all that in with weld. Clayton's going to build a small little spacer. What would we call that? Centering
bit.
Right, because this hole is too big, so we're going to just build a little piece to slip in there, so we'll be able to drill from this way to get a centering hole back to like our home position. So that's the best way to explain it.
Clean up the mess.
And then we'll put it in the mill, or drill press essentially, and drill it out with the injector drill bit.
Make it right.
Get to it. You look good. Show yourself.
Dave bought some goggles. And now this is what we're going to be doing on the lathe.
Okay, so we got a couple of pieces to make this go a little bit easier. This is just an old bolt. Clayton just ran it on the lathe, and I'm going to be able to put that in there so that I can kind of fill the hole easier without having to worry about it. Basically it's like a little backing plate. I don't know if that's in focus. So that's going to give me something to basically weld up against, and because this is steel, it's not going to weld against the aluminum. And then the other piece is just this centering piece. Maybe I showed you already, I don't know, but that's going to go in there. That's going to allow us to drill through this way, to go back through and center out where the injector needs to be. So now I'm just going to use that insert, as I mentioned, and I'm going to start welding it up and filling that hole in. Filling the hole in. Getting seductive. Is that the right word? All right, there we go. Not the best surface finish, but it is what it is. And I'm going to be welding to it and hacking on it a whole bunch more, and it's going to get banged up when I start drilling it out and stuff like that, so I'm not super worried about it. So I just got to deburr the edge and find out the next step of trying to mount this to drill the injector holes now. Okay, so everything was going good until it wasn't. So these holes, although there's lots of filings in there, they're doing exactly what they're supposed to be doing. However, where I welded in this one, it wasn't quite enough and it cracked. So now I got to take it off the fixture, re-weld it, re-center it, and then re-fixture it again just to drill out that hole again. So probably another hour and a half worth of work just to fix that one mix-up. Bogus. Okay, so the manifold flange, intake manifold flange. Since the inner broke off, as I explained earlier, I've opted to basically drill. I'm going to drill all these out completely now, make plugs for them, and I'm going to switch this runner and intake manifold to dual injectors. So I've wanted to do that for a while. I just kind of procrastinated on it. Why I didn't even really think about trying to do it this time, because I didn't expect to be getting this far into tearing this intake manifold apart to do this. But here it is. I'm drilling it out, a few more hours work, but I'm going to do dual injectors, so I'll be running 8 injectors on this thing. And I don't really need to with the injectors that I have. They're 2600s at only 3 bar, so they're huge, but running a smaller primary set of injectors will help a lot with, you know, idle and keeping the fuel cool and stuff like that. So it's something I wanted to do, but I just, again, it's not easy on this intake manifold, especially this flange. But I'm going to just drill it all out, essentially plug it all up so like it's didn't have any injector holes in it at all. And I'm going to make dual injector bungs to weld onto the intake manifold. So let's get to drilling these out and continue on with this process. Okay, now that I'm done butchering this intake manifold for a little bit, I need to pick up some stock to be able to do the dual injector bungs. So now I moved on to the exhaust manifold, which I have to weld in the EGT bungs for it. And on these, they have to be equal length. They have to be in the same location basically across the manifold. So the same distance out from the cylinder head, as long as the runners and the cylinder head are all the same length. On this cylinder head it is. So I'm basically going to mark, I'm just going to use a small bolt, maybe something like this, to mark each one out, and then drill it, and then start welding each one of these little bungs in here. Now I'm going to try to do them all on the bottom. This one's going to be a little bit tougher to weld up and possibly drill, but I think this is the best way to do it. All the sensors will basically go in before this gets put back on the cylinder head, because they need to be a specific distance out into the hole. You can't see that very well, but you'll see it when it's all together. And so now we got to drill these out, and then I'm going to take up all these little tiny bungs and get this part of it done. At least I can move on to something else. So I got this all drilled out, and now I'm just going to use a drill bit to make sure that when the sensor or the probe is down inside the manifold, that they're centered. So I'm just using a drill bit to keep it straight, and I'll just do that in each single runner, and I'll just tack it and then manipulate it so that the drill bit goes straight through all the way. So that way I know when the sensor goes in, no matter how deep it is, which it only has to be, I think 6 to 8 millimeters or something like that on a turbocharged application, but at least they'll all be center exactly as they should be. So now to start tacking this up and see how I make out with this thing. I got this done. I didn't film a whole lot of it because it was actually quite frustrating with these runners being, or these bungs very close to this runner. But I got it all done. The sensor fits very tightly in these, so any distortion after you weld them, the sensor's typically not going to go down in there, so they got to be reamed out, which again made these two very difficult to do. But now that that's all done, I'm finally done welding on this thing, and I'm going to this time probably just run this on the mill just to face this. This end gasket here would blow from time to time as it was slightly warped, and you know, I might have to replace a gasket a season, but it's to the point now where I've gotten it off, and I had always planned to kind of put EGTs in this, so it's time now to face that finally so that it's nice and true and I don't have to worry about the gaskets anymore. So that's basically it for the manifold. I'll probably film a little bit of it when I'm facing it, but other than that, that's done. So hopefully you guys enjoyed this more of the behind the scenes sort of day-to-day kind of process that needs to happen to get something like this together, and all the little pieces and the hours that go into even just one piece of the engine, like the manifold or the intake or exhaust manifold. Like I literally have hours and hours on those now, and they're still not done. So if you guys have any questions or comments, as always, be sure to ask them below. We're almost at 20,000 subscribers, so hopefully by the end of this month we'll finally be at 20,000 subscribers. We do appreciate everybody for following along for any of the projects that we do, including our own stuff. And of course, as always, we appreciate the merchandise purchases and stuff like that. So if you have any questions, ask them below, and we'll see you guys in the next video.